Hello class, in this video I'm going to show you how to find the three measures of dispersion without the calculators. Here we have a very simple data set, 1, 2, 3, 4, 5. Sample size is 5. We have 5 values, 18, 19, 20, 21, 22. So to find a range, we use the formula, maximum minus minimum. Among the 5 values, the biggest value is 22. We notice the 5 values actually is already in an ascending order. 22 is the maximum. Minimum is 18. 22 minus 18 is a 4. So the range of this data set is a 4. Range from 18 to 22. So the range is a 4. Next, we are going to see what's the standard deviation. Okay, here is a sample standard deviation. Deviation. The notation for sample standard deviation is a little s, lowercase s. And the formula is square root xi minus x bar, this way. It's xi minus x bar. What does that mean? X bar is the sample mean. We're gonna have to find a sample mean for the data set. And then we use each single value, the 5 values, minus the mean. And then we're going to raise the deviation. The difference between the value and the mean is called deviation. Raise it to the power 2. And then we add those 5 squares together, I from 1 to 5, because the sample size is 5. And then we divide the sum by n minus 1. N is 5 here, so n minus 5 is going to be 4. And then we take the square root, principal square root. So that's the formula for the sample standard deviation. And let's see how do we get it done, all right? So as I mentioned earlier, we have to find a sample mean first. Let me get a simple calculator. To find the sample mean, we add the 5 values together. 18 plus 19 plus 20 plus 21 plus 22. And then divide the sum. Oh, it happened to be 100, right? It's coincident. Divide the sum by 5. Divided by 5. The sample mean is 20. Sample mean is 20. Okay. So x bar is 20. And then we are going to use each single value in the sample minus x bar. Okay, we have 18 minus x bar, which is 20. And then we use 19 minus 20. So 20 minus 20, 21 minus 20, 22 minus 20. And the result, 18 minus 20 is a -2. So the deviation of the first value is -2. And the 19 minus 20 is -1. 20 minus 20 is 0. 21 minus, oh, typo here, sorry. 21 minus 20 is 1. 22 minus 20 is 2. Okay, so those are the 5 deviations. And now we're going to square each single of them. Let's see what's the square. Square of 92, positive 4. Square of 91, positive 1. Square of 0, 0. Square of 1. Square of 2. All right, so those are the squares. Let me show you where we at right now. Now we have those 5 squares. Next, we are going to add them up. Okay, add those 5 squares together. Pretty simple. The sum is 10. Okay, the sum is 10. So now we have this numerator. The radical has a numerator, denominator, right? Now we have the numerator, which is 10. And then we're going to divide the 10 by n minus 1, which is 4. N is 5, sample size. 5 minus 1 is 4. And then take the square root. So basically, we are looking for root 2.5. Okay, root 2.5. Let me try my graphing calculator. The result is going to be a decimal. Sorry about the delay. Square root second, this one, 2.5. Decimal. How about let's round the 2 decimal places? 1.58. So the standard deviation is around equal to, what is it? 1.58. All right. So that is the approximation of the sample standard deviation. This is a sample, by the way, sample standard deviation. And the last measure of dispersion is called a variance, also sample variance. Sample variance. Notation for sample variance is S squared. Remember the little s represents the sample standard deviation. S squared represents the sample variance. From the notation, you can see the relationship between sample standard deviation and sample variance. Sample variance is just the square of the sample standard deviation. And since we have the approximation of sample standard deviation, the sample variance is going to be, you know what, actually we don't have to round it, because remember sample standard deviation is a rule 2.5, right? And the sample variance would be the square of the sample standard deviation. And the square cancel the square rule. We have 2.5. The variance of the data set is 2.5. All right, I hope the demonstration helps.